Hey everyone, welcome back. So today we are going to learn two important concepts based on binary search, which is lower bound and upper bound. So these two concepts are very important because we will be going to use in most of the problems. So before moving to the lower bound and upper bound, let me explain binary search once more. So in binary search we were having sorted array, right? And we are having a target and we have to find that target in the array, and the time complexity should be log n. If we try to find using standard method while iterating over all the values, it will take big of n. So we used binary search because in binary search in every iteration we are kind of reducing our search area, right? So initially we had low here, high here, right, and we were finding the mid. So to find the mid we need a index number of the low and index number of the high and divide by 2. So the mid will be 2, so our mid will be at this index. Now we will match 5 is equals to 7. No, 5 is smaller than 7. True. That means we need a bigger number. If we need a bigger number, then we will move our low. So low equals to mid plus 1. So our low will be at this position. Right. Now again we will calculate the mid. So 3 plus 4 by 2, it will be 3. Right. So our mid will move to the third index. Now we will check again. 7 equals to 7, condition true. So from here we can return or we can print it is available. So the number of iteration it took to search our element is 2. So the time complexity is log n. Okay, so the time complexity log n is it because we are dividing our array by 2 every time, right? Because we had a mid here, so our array got reduced to the half of the full array. So in the next iteration then this will reduce to the half, right? So at every iteration it will be reducing to the half. Now the code was like this. We had a low equals to 0, high equals to n minus 1, and we were running a loop while low less than equals to high, right? Because if high crossed low means our high maybe comes here and low comes here. That means we weren't able to find our value. So in that case we can break our loop. Then we will calculate mid, low plus high by 2. Then we will compare array of mid equals to target. We can simply return index. If array of mid greater than target, that means we need a smaller value, so we will move our high, else we will move our low, right? This was the code for the binary search. Now the concept we have to learn today is lower bound and upper bound. So let's first look what is the lower. So lower is smallest index such that array of mid greater than equals to x. So what it is saying that you have a value x, or you can say target, and you have a value at the mid. If it is greater than equals to, then we can say it is a lower bound value, but we need to find the smallest index. So let's take an example. So we have value like this and we have x equals to 2. This is our target, right? So we will start our low here, high here. So mid will be 0 plus 7 by 2, it will be 3. So our mid will be here, right? Now we will compare target equals to array of mid. It is true, right? So we were able to find our value, but we have to find smallest index. The index at this value is 3, but we have smallest index is 1 for this value, right? If we have a possibility of having smallest index, we will continue our iteration. So first we will update our answer equals to 3 with this index, okay? Because it may happen that it is my one of the answer. Now we were able to get our answer. Now there is a possibility we can get a smaller answer, so we will move our high. So our high will be mid minus 1. It will come here, right? Now again we will calculate mid, so it will be 0 plus 3 by 2, so it will be 1. Right now we will move our mid here. Now again we will check if it is equals to 2, right? We have value to target also 2. Now we will compare our index. It is smaller than this, right? So we will update our index here because we were able to get a smaller index for the target value 2. Now it may happen there may be a chance of getting a smaller index. So again we will move to the left. So our high will come here and our mid will also end up here. So if you look at it, it is not possible, right? 1 equals to 2, no. So the last answer we have saved is 1, so the answer is 1. Okay, so that's the smallest index we were able to find for the target value of 2. So you can say if you have repeated values, then you have to just return the smallest index. Okay, if you had a target of 3, then your index would be 3. Okay, so let's take one more example. Let's say if my target was 5, which is not available in this array. In this case, it will return me the last n index, because in this series we have last value is 4, so there may happen that there is a value which is out of the array. So for this case we will just return our n. Okay, so let's take one more example. We have this example. We have x equals to 3, so lower bound value will be 3, right? Because it is greater than equals to the x. Let's say if we take x equals to 5, is 5 available in the array? 5 should have been here somewhere, right? But it is not. But what we are writing greater than equals to x, so our mid will be 2. We are returning the index, so it will return the index for this value because it is just greater than the 5 and we are using greater than equals to. That means it will first find the equal value, then it will find the greater value. Similarly, if we take x equals to 12, 12 is not available and the largest value we have 11. So in this case we will return an index, and is here 5, right? So these are our lower bound. So in lower bound we look at the greater than equals to. So first it will try to find value equal, then if it is not possible then it will look for the greater value. In this example it was able to find equal value 3, so it returned the index 3. In this example 5 is not available, so 6 is available, so it will return index of the value which is greater than the 5, which is 2. Similarly for this 11 is not available, so 11 is our last element, so it will return the n index which is greater than the n minus 1. So this is the lower bound. Similarly for the upper bound we have to look only greater value, means we still have to find smallest index, but we are looking for the greater than x value. So let's take an example. 1 2 2 3 3 4 7 8. So we have this example. If we have x equals to 2, right? So 2 is available in this array and we have smallest index for the 2 at this position, which is 1, but upper bound is asking for the greater than x value. Greater than x value is 3, right? So the index will be 4. So this time we are not considering equal value, we are considering only greater than x value. Okay, similarly if we take x equals to 4, so the 4 is just greater, so we can take 7, so it will be 7. Okay, here index is a 7. Okay, so in lower bound we look at the greater than equals to x, in upper bound greater than x. In both cases we are trying to find a smallest index. So in lower bound and upper bound also we are trying to find the value, so we can use binary search code, and both will be using same code. There is a slight change in our code which will be here because we are trying to find the target, right? And this time we are not finding exact equals to target, we are trying to find greater than equals to and greater, right? So for the lower bound the change here will be greater than equals to, and for the upper bound the change is greater than for this equals to. So we just have to change this equal, because we are not finding exact target. This time we are trying to find smallest index for that same target. So let's write the code. So I declared an array which is having value 1 2 2 3 4, and our low is 0 and our high is 4, right? Because array size is 5. Now we will run a loop, low less than equals to high, and we will calculate mid at every iteration. So low plus high divided by 2, and after this we will compare. So here we have to declare one more variable, index 5. So the initial 5 is because, let's say if you weren't able to find any value in this array, in that case it will return the index 5, because it may happen that our value is outside the array. Now we will compare ARR of mid. If it is greater than equals to, let's say this time we are taking target 2, we can say it may happen that it is one of the answer, so we will update our index with the mid. Now we need a smaller index. If we need a smaller index, we will move to the left, else we will move to the right. Let's print our index. Okay, so what's happening here? We declared a low, a high, and index initially 5, right? And we will run our loop and we will calculate mid, and we will check if my value at the mid is greater than equals to 2. That means we can still find a smaller index to the left side. So we will first update our index, then we will move to the left, else we will move to the right. So let's run this code. So here you can see it is printing me the 1, which is index 1, right? So our smallest index for the target value 2 is 1. Let's take another target value which is 5, right? So let's run it. So here you can see for that value 5, it is printing me the 5. Let's take 5000 for the target value. So it still printing me the 5. So here you can see it is still printing me the 5. So if there isn't a value available, we will just print our AND itself. Okay, so this is for the lower bound. So in lower bound we are looking for the greater than equals to value, and in upper bound we are looking for the only greater value. So let's take target 2. So this time our index will be 3, right? Because 0 1 2 and 3. So it is asking for the greater value, so it will not consider 2, it will directly jump to the 3, and the index for the 3 is 3, right? Similarly for the target 1, it will return the index for the value 2. So index 1, so we have given the target 1, so it needs a greater value. So greater value is 2, right? And the index for this value is 1, so it will return 1. So lower bound will return me the smallest index greater than equals to x, and the upper bound will return smallest index which is greater than x. So only difference is greater than equals to x and greater than x. So these are the code for the lower bound and upper bound. Okay, I hope you able to understand how lower bound and upper bound is working. If it is not clear, then go watch it again. It is really simple concept. So that's it for today. Until then, thank you everyone. Have a nice day.